these, like I said at the beginning, should look very familiar to what you did in chapter 7. These are exponential equations. Okay, and last time what you did, maybe I'll just give you an example to refresh your brain. If I had something like this, what did you do when you solved an equation like this?
Took away the bases.
Yeah, you said, okay, if the bases are the same, then the exponents have to be the same, and then you solved for x, right? Or if you had something like 2 to the 3 equals 8 to the 2x, you had to rewrite 8 with a base of 2, and then you were able to take away the bases. Okay? Question, can you do that here? Can you rewrite, in this case, 605 with a base of 4?
Nope.
Probably not, because it's not even, right? So we're going to run into a little bit of trouble there. So this is where logarithms really shine. Okay? What we're going to do is we're going to take this equation and write it in logarithmic form, which would be what?
Log 4.
Log 4.
Wait.
605.
That's what.
Thank you.
I meant to
base
say,
of 4.
With a
I
base
meant-
of 4
I
equals
always just say log 4, 6.
equals x, right? Look at that. X is solved for. Kind of like instantaneously.
We're wrong.
Okay? So now all we do is just evaluate log 605 base 4. So go in your calculator and go log 605 divided by the log of 4. Tell me what you get.
4.62.
4.62. I forgot.
Do you have to do that? Like divide by log 4? Can you actually just enter the log base 4, 605 and get...
If your calculator allows you to enter things like this, that's fine.
Okay.
If it doesn't, which the TI3s and TID4s don't, you have to do it like this. Okay? One thing we didn't do is look at restrictions for x. Do we need any restrictions on x?
Nope.
Why? It's an exponent this time. What kind of numbers can exponents be? Anything. Right? They can be 0, they can be negative, they can be positive, you're fine. Okay? So this is the true value of x, 4.62.
Which makes sense.
Good?
It does. Yes.
Okay?
Because 4 to the power of my answer is 605.
Let's go to the next one. 8 times 3 to the 2x equals 568. What do I do? Question, can I go, well, 8 times 3 is 24, so 24 to the 2x equals 568. Can I do that?
No.
You can't.
Well, you didn't do anything to explain.
Can't you do
explain that.
568 divided by 8?
Hmm?
Can't you do 568?
You can divide out that 8. But you cannot multiply these two values together. You see why? Yeah, you can't combine these. You can't combine these unless they have the same basis. Okay. If you don't believe me, just think about doing something like this. Take 5 and multiply it by 2 to the 2. That's 5 times 4, right? So that should equal 20. However, if I multiplied those bases, that would be 10 to the 2. That's very different. That's now 100. Okay? So the point is, don't combine these unless they have the same base. All right? In which case you would add the exponents. But yeah, be very careful there. So like Nathan said, we're going to divide out that 8. Okay, from both sides. Just gives us something a little simpler to work with. So 568 divided by 8 is how much? 71. Okay. Now what?
Now we can
Put it in the
Logarithmic form. Okay, so log 71 base 3 is 2x. And again, x is partially isolated. That's nice. That's what I meant to say. Isolated and nice. Okay. From here, you could just go 2x equals log 71 over log 3 in your calculator. And then you could divide by 2. Right? So what is this? Log 71 divided by log 3.
3.88.
3.88. Blah, blah, blah. And then divide out the 2. 1.94. Okay. Any restrictions? No, again, because it's an exponent, so we're safe.